Alright, today I'd like to talk a little bit about factoring and greatest common factors. Here are the definitions of prime numbers and composite numbers. You should actually know this, and if you don't, just read them over and write down the notes. Here's a good question, though. How come 0 and 1 are neither? They're not prime and they're not composite. What are they? Let's look at prime factorization of a positive number first. Again, stop the video and copy these notes if you need to. So let's find the prime factorization. Yeah, let's find the prime factorization of 90. So example 1. Find the prime factorization of 90. Well, there are a bunch of different ways to do it, but let's try this way. The first thing I would do is this. So method 1. My grandfather used to always say, when there's an emergency, start by doing something. So let's do something. So here's 90, and remember, we're looking for prime factors. So let's see if we can get one of them out right now. This is 90 ends in the number 0, so it's divisible by 2. So here's 2 times 45. So there's a start, isn't it? And we know that 2 is prime. So we're going to go ahead and gather this piece right here, aren't we? So that we got that 2 right there. And then let's look at the 45. So we have 2 times. What can we get out of this? What prime number can we get out of this? What's the smallest one we can get? Well, we know that this is factorable by 3, right? Because there's a rule for divisibility by 3, and if you add the two digits together and you get a number divisible by 3, then you have a number divisible by 3. So 45 is the same as 3 times 15. We have the 2 and the 3. Is 15 prime? I don't think that it is. So here's the 2, here's the 3, they're both prime. How can we rewrite 15? Right? Let's take the smallest prime number out of that, which is 3, isn't it? 3 times 5. And then let's just check. Is 2 prime? Yes. Is 3 prime? Yes. Is this 3 also prime? Yes. Is 5 prime? Yes. And then we have to do something that's really important here. Let's multiply. 2 times 3 is 6. 3 times 5 is 15. 6 times 15 is 90, so we still have our 90. So the prime factorization of this number is 2 times 3 times 3. It's often rewritten this way, 2 times 3 squared. So is still the prime factorization of that number. We can also do this exact same thing by using the second method, which is a factor tree. So method 2 is a factor tree. So we could try that. We could try factoring this thing like that. So we could use a factor tree here, and the factor tree just does the same thing. It's just more. And then we do the same thing. It doesn't matter how you do this. People get all freaked out. Well, what do I do first? Find two numbers that multiply to give you 90. So I don't care what those two are. The book uses this. Let's use 6 and 15. 6 times 15, which is not what the book uses, but let's go through, because my point to you is it doesn't matter what you use. Ask yourself, is 6 prime? Yes or no? It is not prime. So what are two factors of 6? 2 and 3. Are 2 and 3 both prime? Yes, they are. So going to get this, aren't we? Do this. Going to get this here and this one here. These are both prime, so I'm setting these aside. Then I'm going to look at this and say, factors of 15. Factors of 15 are 3 and 5, 3 and 5. They're both prime. So look, we got the same factorization as we got before. What I'd like you to try is try it with different ones. The book uses 9 and 10. See if it doesn't break out to be exactly the same thing using the factor tree. As long as your factors work, as long as your factors are true, you can't have a number times a number that's not equal to 90 and hope that you're going to somehow or another get the prime factorization. But as long as you're making good sense. Okay, let's move on to the next idea. It's really easy, I think. Prime factorization of a negative number. And all you're going to do is this, is find the prime factorization of 140, of negative 140. Negative 140. All we're going to do is this. First thing we do is going to pull out the negative 1. Right? And then we're going to work on the factorization of 140. So here's our negative 1. And this one might be, I don't know, 2 times 70, I guess. 2 is prime, isn't it? 2 is prime. So we have this one and this one captured, right? I'm just capturing the work that we have completed. I don't need to work on those. Here, 70 is, I don't know, 7 times 10, I guess. 7 is prime, isn't it? That worked good. 10 is not prime. 2 times 5. 2 times 5. Do a little bit of math here. 5 times 2 is, I'm sorry, 5 times 2 is 10, times 7 is 70, 70 times 2 is 140, 140 times negative 1 is negative 140. We got back to that number that we started at, didn't we? And then all I'm going to do is all these numbers that I put little squares around, I put them there for a reason, is that's my prime factorization. So I have times 2. So that I use this one, I use this one. I'm going to use this one here for a reason. Times 2, whoops, sorry, times 2, times 7, times 5. Used them all. Again, I'm going to check my math again. And when I do my multiplication backwards, I get the same number back I started with. That is the negative 140. I can do it this way. 2 times 2 is 4. 4 times 5 is 20. 20 times 7 is 140. Times negative 1 is negative 140. So that works. So this is the prime factorization. Better written this way, though. 2 times 2 is 2 squared, isn't it? Remember, don't put 4 because 4 is not prime, right? So you don't want to simplify this, right? Times 7 times 5. Done deal. All right? Okay. I think we're going to leave that at that for right this second and then come back and do a second video. You know what? We have a minute. Let's do this for a second. Let's find the prime factorization of this. You know what? Let's call it a day, and I'm going to do another video in just a minute on this, okay? Make sure you know what prime and composite numbers are. Make sure those are in your notes, okay, guys?